How's it going, everyone? This is Finance Made Easy, and welcome to my first video where I'm going to be discussing net present value. So, to start out with just kind of like a really easy explanation of net present value, essentially, it's a technique used by management to determine whether a project or investment should be made. And it does this not only by taking the time value money into consideration, but first it will project any kind of future cash flow that they think the project or investment will make in the future, and then compare it to the initial investment that's going to be made. So from that, you're dealing with cash flows over different periods, usually years. And I'm going to be going into the math later and giving you guys more of a explanation with examples. But essentially, what you need to remember, there are two, and you can, depending on your professor, there are three things you need to remember about the ultimate value of your NPV. If it's positive, you want to go ahead with the project. If it's negative, you do not want to go ahead with the project. And if it's zero, which from experience I've never seen in the real world, but your prof may do it to test you and just kind of be a pain in the ass, but it really all depends. Usually, if your NPV will be zero, the explanation is that the rate of return equals the discount rate. So whatever your discount rate is, whether it's the cost of capital, weighted average cost of capital, again, all these numbers are projected, nothing's certain, especially when it comes to discount rate, but essentially all it means is that your projected rate of return equals the projected discount rate. And I remember in my corporate finance class, I was asked that question, what happens if the NPV is zero? That's really all that you have to remember. In the real world, a manager would see an NPV of zero and think, okay, what are some ways that I could make this project or investment profitable? And I can always go into that into later videos. So the first thing I like to do when tackling NPV questions is to first write out the formula. So NPV equals CFT over 1 plus R to the T. And these periods right here indicate that you're going to have to add future cash flows together in this same kind of equation format. So if cash flows are $1,000 and your discount rate is 5%, what it's going to look like is 1,000 over 1.05 to the first. And if there's a second period or year of cash flows of $2,000, it's going to be that plus 2,000 over 1.05 to the second, right? So these two T's, they're similar in the aspect that you're taking into consideration the same year. However, you're not multiplying your cash flow by the period like you are the discount rate, if that makes sense. So all this is the cash flow is showing you is that the cash flow for year one is 1,000, but your discount rate is going to be multiplied by 1 because that's the period that's you're taking into consideration. For the second time period, you're not going to be multiplying the second cash flow by 2. That's right here is signifying that that's just the second cash flow period. And that's why I'm not having it as an exponent showing that you need to multiply it. So once you figure all that out, you just simply subtract it from your initial investment, and then you're going to get a number that's either positive, negative, or zero. That's going to show the potential profitability of the project or investment at hand. And so written out, essentially just in layman's terms, the NPV equals today's value of expected cash flows minus today's value of invested cash. So let's do an example. The project starts on January 1st, 2007, and will finish on December 31st, 2009. So the first thing I'm thinking is this going to be 3 time periods. The project financial data includes the initial investment of $50,000, the discount rate of 10%, and then the cash flows for years 2007 is $2,000, 2008 is $10,000, and 2009 is $75,000. So one extra thing you can do is, I always like to first think of whether this is going to be a negative or positive NPV. And first, obviously the initial investment of $50,000, if your first year you're returning $2,000, it doesn't look so good. $10,000, not so good, even with the discount rate of 10%, which is pretty high. In the real world, you usually do something, if you know your definitive, WACC or cost of capital, you're going to use that. But, usually you do something around 6 to 7% because when you're doing this, again, it's all hypotheticals, it's all projections. You want to be conservative in your projections so you don't, end up effing everything over by saying I'm going to have an 18% discount rate or an 18% rate of return, because that's just ridiculous, But anyways, your cash flow for the third year is going to be $75,000. But again, that's going to be over 1.1 to the third. So you've got to think in your head, okay, well, this $75,000 is going to be divided by 1.1 to the third. It's not going to be worth $75,000 in today's money. Again, NPV is taking all the future projected cash flows, and the reason why you divide it by like 1 point discount rate to the respective exponent is you're regarding for inflation. A dollar today is worth more than a dollar tomorrow. If you've learned the time value of money yet, that's essentially saying that inflation is going to steal the value of your dollar over time, even if it's like 2 years from now or a year and a half from now. So do you recommend to do the project? So let's try to do this question. I'm going to walk you through this first before I have my second example where, you can pause the video and try it yourself. But this is how I would tackle this problem. First, I'm going to write out the formula, right? And we have 3 different periods. So we're going to add 3 different cash flow over 1 plus r to the t. Essentially, after I write down the equation, I try to figure out the info that we know, right? So the initial investment is $50,000, the discount rate is 10%, and the cash flows for year 1, 2, and 3 are 2,000, 10,000, and 75,000. And if you want to pause the video and try to set this up, feel free. But going ahead, this is what your setup should look like, right? So the first year is 2,000, discount rate's 10%, so it's going to be 2,000 over 1.1, and t, the time period, is year 1. So you're going to have 1 here. Second year, 10,000 over 1.1 to the second. Third year, 75,000 over 1.1 to the third. Mathematically, these really aren't that difficult of problems once you get them down and once you practice them. But again, remember, with NPV, you're not just doing a usual DCF. You have to take into consideration the initial investment. So once you set up your DCF, you subtract 50,000 from that. The answer is going to be $16,431.25. Obviously, very positive NPV. You want to go ahead with that project. Another thing with NPV that you need to take into consideration is salvage value. How I like to think about salvage value is that it's essentially something that you add to the respective cash flow for that period. You have to incorporate the salvage value into your equation somehow. What I've seen salvage values in problems have been, usually you see it in a question if the item in consideration is sold after the last year, or if whether that's a machine or an investment is, sold. So essentially what you do is you simply add the price sold to the cash flow of the respective year. For example, if a machine is sold at the end of year 6 for $500 and the cash flow for year 6 was $3,000, you'd have your cash flow for year 6 be $3,500 total and not $3,000. So again, just remember to add the salvage value to the last respective cash flow, and then just, it's just math from there. It's just setting it up like you did in the last problem, but adding the salvage value to the last year, or whichever year, it was sold. So this is going to be a little harder of an example because you incorporate salvage value. So initial investment of $8,320 on plant and machinery is expected to generate net cash flows of $3,321, $3,021, $1,043, and $1,129 at the end of the first, second, third, and fourth year, respectively. At the end of the fourth year, the machinery will be sold for $900. Calculate the NPV with a discount rate of 18%. Now, First of all, your initial investment is 8320, and taking into consideration, the cash flows, they decrease. Except the last year, you're going to incorporate an extra $900 into the 1129. It looks like this may be close to zero or slightly negative or slightly positive. You never know. But the other thing you need to realize is that the discount rate is quite large at 18%. So that's something else that you need to take into consideration. So first things first, you write out the equation, and then let's write out all of the info that we know. The initial investment is 8320, discount rate is 18% or 0.18 mathematically. Cash flows for year one, $3,321. Year two, $3,021. Year three, $1,043. And year four, remember you have to add the salvage value, so it's going to be $2,029. Now, if you want to pause the video and try to set this up, go for it. We'll see if you can get it. So this is how it's going to be set up. Essentially, there's going to be 4 periods. So T is going to go to a maximum of 4. Again, this is pretty straightforward. And then just remember to subtract, the 8320 or the initial investment. The other way that, you might see this is you might have the initial investment in the front and you subtract it from there, but either way, it's going to be the same. So your answer is going to be negative $1,654.62. And that's a negative NPV, so you do not want to go ahead with the project. Thank you for watching. If you have any questions, please comment. I'll try to answer them. But yeah, have a good day and good luck.